Welcome back. Last time we sort of discovered that I didn't really like the expanded shale in here because of the weight. So this video we're going to take a little side project and deal with how I'm going to keep the plants irrigated. These videos are brought to you by our Patreon contributors. Our top contributors are aquaponics.ai, growpockets.com, trueaquaponics.com, and glassbottleoutlet.com. Thanks for your support. You might recall before I went down the path of filling these up with expanded shale, the original plan was to set up some foam board on top of the troughs and then just hang the plants in there and just water the roots while they're just in the air. So we're going to go back to that original concept. One of the main reasons why I didn't want to do that was just figuring out a way to do the irrigation. My initial thought was to put these in here and then run a pipe down the entire length that would be used to carry the main water into this, and then basically put drip emitters in just like a standard hydroponic setup would be. But the issue with these are with these small emitters, they will tend to clog, especially with the aquaponic water, unless you install some filtration system on, and then you're spending all your time dealing with filtration and having to clean that out. So that's why I really sort of abandoned this and went with the expanded shale instead. Doing this, I think what we're going to do is try to irrigate from within the trough itself, which leads to other potential issues, but I have a couple thoughts on how to deal with that. Let's take a look at the cross-sectional view of this whole thing. This is the bottom of the trough here, and then a plant will go in here. We've cut out the other half of the cross-section, but there's basically plant holes also here. They're spaced about 7 inches apart diagonally, and so there's going to be a bunch of plants that are in here. So what I'm thinking about doing is putting that main feed line inside the bed, right along the bottom here, and then in the bottom just drill a bunch of holes in that main line and put some short nipples in here to feed water up to some type of a sprayer that's up in here. And so what the goal will be is to get the water to essentially come out and spray onto the roots just in each of these directions, so it will come like this. And the main reasoning why I want to spray up higher like this is the roots are going to be fairly young on some of these plants, so they're just going to be hanging down a little bit at first. It won't be down along the bottom. So a lot of people have actually suggested just installing an NFT system. I would have to shorten this up and then flood the water fairly deep, and then I'm going to get back into having to deal with a large volume of water in here, and I don't want to have to deal with that. And if it was more of an NFT, the water level would just be down along the bottom and the roots aren't going to meet up with the plants that are in here. So I want to get something to spray in here. I'll put it on a timer and just spray every once in a while. That'll help keep the roots from getting too wet and starting to rot. And then as the plant continues to grow, the roots will just sort of come down and go into the bottom. And I'm expecting down in the bottom there'll always be some water down in here, just from it draining out. But at least the crowns of the plants and the bulk of these roots won't be saturated in water all the time. So let's spend a little bit of time trying to design up a nozzle for in here that we can flow water through and it won't clog up. One other reason why I want the nozzles to spray up higher here is because if the roots were growing down and they start getting way down into here, if I had a nozzle that was setting much lower and spraying down in here, eventually the roots are going to grow down into this nozzle area and probably clog it all up. So my thought is if I can keep the nozzle up high in here, as the roots grow down, it will always be safe from any roots getting into this, because they're basically hanging here, and when roots are growing, they're just going to grow straight down. They aren't going to come out like this and hit this. So it'll just sort of come down and drape down and start accumulating down the bottom. So these nozzles should always stay clear. Before I get into my design considerations, let's take a look at a few options that are already commercially available. First up are these ultrasonic foggers that are used in hydroponics. I'm not a fan of using these in the aquaponics. I think there's just too much debris and whatnot that's potentially in the water. These need to be in a reservoir, and I'm not a fan of having to add weight back into the system to have a reservoir in the bottom of my trough. And they float on these little rafts. These emitters have to be a certain depth underneath the water for them to work properly. So having a reservoir, keeping everything perfectly level, also having power going through this, I'm not a big fan of that. I mean, they do a great job with their irrigation and fogging, but it's just not something for me. Next up, very common using in the aeroponics are these misters, and one of the nice things about these is that they can be directed in certain directions. This is a 90-degree, so I could shoot it in two different directions. The biggest issue I have with these are that the orifice for spraying out is very small. So to get a good misting out of them, you need to have some fairly good pressure. These are rated for 20 psi. I was hoping to keep it down to maybe 1 or 2 at most with my system, just to cut on electricity use and whatnot. The orifice is so small in these that they are prone to clogging. In hydroponics, it's not much of a big deal, but in aquaponics, it's all types of debris going through the water. And I just don't want to have to deal with filtration system beforehand, because then I'd be cleaning that out instead of cleaning out these emitters. So these are nice, but not going to really use them. Last up are these spiral emitters. Now these are pretty nice because they have a fairly large orifice for the water to come out, so they're much higher volume. The biggest issue with these is that they just spray everywhere. They're designed for like cooling systems or large irrigation, or for even sprinkler systems for fire suppression. So you can't really direct the water to go anywhere with these. They work well, but for my application, I don't think they're going to do the job. So the plan is to take a piece of this 1-inch PVC piping, use that as the main supply. It probably should be larger than that, 1.25 inches or 1.5 inches, but I have a whole bunch of this on hand, so we're going to cheap out and try it this way. And then I'm going to drill a whole bunch of holes in it, 1/2-inch holes every 6 inches. Now that 1/2-inch hole is a hair smaller than the size of a piece of 1/4-inch PVC piping. The 1/4-inch piping is just a nominal size, and they're really just a little bit over 1/2 inch in size. So what the plan is to take the end of the pipe and taper it just a little bit so it can slide right into this piping and wedge itself into it. And hopefully that will eliminate the need of needing to thread these two together. If I just pound this in, the friction fit should be sufficient, especially with lower pressure systems. If I only have a couple of psi in it, it should be fine. And then for the sprayer system, it's just a little simple sprayer here that will also friction fit right on top of this. And that way I can adjust the angle of it if I want to. So let's take a look at the sprayer unit. Let me make it transparent here so we can see everything inside of it. In the bottom here, this is where the nipple wedges up into it. These are actually a tapered side. And the bottom of this matches the inner diameter of that piece of tubing. And then we taper it in a little bit, trying to keep a little laminar flow into it, get it a little bit smaller. And that will shoot out and actually split on either side of this. And that laminar flow should fan out and then spray out nicely in here. Here's a cross-sectional look of that so you can sort of see what's happening in here with the water coming up, splitting against this and shooting out on either side. So here's my first prototype. Made up a piece of PVC scrap, drilled my 1/2-inch hole in it. Also took this and tapered it down just a hair. I chucked it up in my lathe and turned it down that way, but it would be easy enough just to put this in a drill, make it spin around, and hit this with a file or a piece of sandpaper. That jams into there. This jams onto this one. And we have one instant sprayer. Before I start mass producing these nozzles, it's probably a good idea to test it out and do some long-term checks with it to make sure that it's going to be okay. So just sort of get that set up. It's sort of hard to see the spray against the blue background, so I just have it over the water now. This is a pretty good spray. It's way too far. It's shooting out about a meter. This pump's a little oversized for this, but if we throttle it down a little, I can get a spray like that. And if the roots are only 3 or 4 inches away, you'd be hitting against a plant like this. Or depending on how I set it up, I could actually get it to pass one set of roots and hit the other plant, get a little crossover. So this method would probably work pretty well. From a side profile, I'm a little concerned about the laminar flow here. If the plant is here, yeah, the crown area will get hit with the water, and I'm sure it would just drip down like it is on my finger. But I'd like to get a little bit more spraying up and down just to get a little more coverage in here. So I think we're gonna try another experiment and see what we can do about that. And here's a little slow-mo of everything running at 1/8 speed. Here's what I call my teeter-totter design. So now what happens as the water comes shooting up through the center here, it comes on this side and jettisons itself out on this way, and that action actually forces this movement to come this way, which then the water wants to go on the opposite direction. So this will just keep oscillating back and forth, spraying water in each direction and at different elevations. So here's our first 3D printed one, and we'll bring it out and see how it works. From a top view, this looks good. I get a little bit of a spread this way. There's a lot of water droplets in here. It is running a little faster than it should be. The camera shutter speed isn't fast enough to get all this, so we'll do a little slow-mo in a minute. We'll slow it down a little bit. That's about where it should be running at. And again, it keeps tottering and spraying out in a pretty good pattern. So I'm overly happy with this one. And as long as it mechanically doesn't fail or clog up, I might go with these instead of the other style. The side profile looks good too. Now it's not just spraying out in one direction. So if the roots are hanging down here, more root area is going to get hit by at least some kind of a water droplet. So this looks pretty good. This design here has gone through 7 or 8 different versions. I had some problems with the first couple of versions with it oscillating properly. Sometimes it would just center itself and spray in both directions. Sometimes it would just oscillate and get stuck. Sometimes it would work for a while and then get stuck. So I think this one's going to be a winner, but we'll set it up for a long-term trial. Run some debris from the bottom of my DWC bed through it, just to make sure that it doesn't clog up. Now that I'm happy with the design, I made up this test jig that holds 10 of these, and we're going to let this run for a while to make sure nothing bad happens with them. We'll see what happens. One of the spray nozzles came off last night. I came down to find this, so we're gonna have to address this. I may not have put it on tight enough, but what I'm speculating is all the vibration of these things running, they just work themselves free. This is the second one that's done this to me, so we definitely have to assess this. I don't want these failing when it's running in the system. Now, after a little redesign work, we've ended up with the same teeter-totter mechanism. Now there's this long neck built into it, so instead of threading a small system into a nipple, which they cost about $2 a piece, I just molded the whole thing into one big piece, and so this whole thing cost maybe about 50 cents in resin. And then at the bottom section here, it is an NPT threading for a 1/4 inch pipe, so it's a little tapered threading that can screw into the piping, and then also a little square. Taking a look at the cross section view, here's our pipe, and then the water can come right up through this channel, and it slowly gets narrower, makes a nice laminar flow, and jettisons it up into this top mechanism, just like before, and then it teeter-totters back and forth. Alright, so the first one's printed out. The top is essentially the same as the original design, but now that there's the nipples just integrated into here, the bottom has a threaded NPT tapping, and then this last little square part so I can get a wrench around there. Here's the piping that's now threaded, and that's just threaded with a standard tap. Doesn't take much to especially thread plastic, so it's very easy. Then that will just screw into here, and then use a wrench on this nice square part, just basically so I don't have to use like vice grips or something to crank it in. I don't want to break the plastic. And that can go in nice and snug and twist to whatever angle that I need it to be twisted at. So let's go down and test this and see how it works. Tubing's not very tight on those threads, but it may blow off, but at least I'll get a little test in here before it falls apart. This is really the speed where this is going to be running. So I guess this is a good spot to end this video. I seem to be taking a lot of side tangents on little projects like this and the brake system and everything else. But I need to let these run for a while just to make sure that they're going to last for the long term. So while these are running, I need to print out a whole bunch more, and then I'll get ready for the next video. Thanks for watching.